Assalamualaikum. My name is Zayazmi bin Zaidi Anwar. My matrix number is CF220138. Okay, so today our group we're going to discuss about project calculus project. So the purpose of this project there are two problems. The first problem is to solve the problem of the traffic data in front of SMK Sri Gading on 2nd February 2021 from 10 a.m. to 12 p.m. off peak in Kluang Batu Pahat. Problem 2 is experimental testing of concrete prism under flexural load by using the application of differentiation and integration.
Day to Dr. Noain. My name is Angija, matrix number CF220179. Now I will present the average speed vs time graph. At here, this is the data for the average speed and time. And this is the graph for the average speed vs time, as the average speed as the y-axis and time as the x-axis. And I will show the polylinear line too with the equation of third order. From the equations, I have do the first derivative for the value of x, which are 1.2989 and negative 0.6825. So from these two values, I have do the intervals, which is negative 1, 1, and 2. And insert these three intervals into the first derivative equations, and I have get for the negative 1, the sign of fx is positive. For the 1, the sign of fx is negative, and however, the intervals of 2, the sign of fx is positive. So at here we can conclude that the intervals of negative 1 and negative 0.6825 is increasing. However, the intervals of negative 0.6825, 1 and 1.2989 is decreasing. At last, the intervals of 1.2989 and 2 is increasing. About the rate of change of the 50-minute intervals, using the formula rate of change, which is y2 minus y1 over x2 minus x1, and get the y value by using the equation from the graph by inserting the x value, which is the time. So at here, the table has shown the rate of change that I have done by using the formula. At here, I will calculate the relative maximum number and absolute maximum and minimum number. So at here, I will do the second derivative from the first derivative, and then I will insert the two x value that I have get previously. For the x value of negative 0.6825, we have inserted into the second derivative, and we get negative 19.405, which is negative value and less than 0. So then we also put the x value into the original equation to get critical point for the x critical point. So at here we can conclude that the x value of negative 0.6825 is less than 0, which means it is convex downward, and it has a critical point of negative 0.6825 and 82546 as the y value. However, for the second x value, which is 1.2989, at here we also do the same procedure, inserted into the second derivative equations, and we get 90.405, which is the positive value, which is bigger than 0, and we also get the y value of this x value, which is 69.848. So at here we can conclude that critical point is 1.2989 and 69848. And it is concave upward. And at the graph that I have shown here, it is the maximum point and the minimum point that we get from the calculation that I have done just now. And this is the end for the average speed vs time. Now is the graph for the cumulative volume vs time. At here, this is the data for the cumulative volume and time that I have calculated, and also the graph that I have done by using the Excel, which is cumulative volume as the y-axis and the time as the x-axis, and polylinear trend line also shown here with the equation of second order. Then this is the rate of change for each 50-minute interval for this cumulative volume vs time. At here, I'm also using the same formula of rate of change, which is y2 minus y1 over x2 minus x1, and I also get the y value by inserting the x value, which is the time, inside the original equation that I get from the graph. At here, this is the final answer of the rate of change that I have done by using the formula that I have mentioned just now. Each interval of the rate of change has been calculated. At last, we will sum it up and divided by the 7 intervals. At last, the average rate of change we get is 203.
Next step for solution problem number 1 is relative maximum number. The second derivative critical number for x1 is negative 2.177 and x2 equal to 5.127. Substitute the value of x equal to negative 2.177 and the answer is 219.822. So the convex is downward. When x equal to 5.127, the answer is 321.654 and the concavity is concave upward. Next, substitute the value of intervals into the second derivative equation. For negative 3, the answer for x is negative 10.4877. For 0, the answer is 17.502. And for 9, negative 67.8837. From that table, the function is decreasing in the interval negative 3 and negative 2.17703 while increasing in intervals of negative 2.17703 and 0 and 0 and 5.12684 and decreasing in the interval of 5.12684 and 9.
My name is Muhammad Firzaidi bin Muhammad Hamadi, CF 2210123. I'm presented problem 2. From this problem 2, we have to plot graph for Church range with S deflection and find energy of concrete can be calculated by finding area under the graph. So by the method 1, we find how to calculate graph and linear because of flexure strength with S deflections. That means Newton with S meter. We divide area by 6 portion, A1, A2, A3 and L4 and 5 and A6, and we calculate using trapezoidal and triangle by sides.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakim bin Abdul Rahim. My matrix card number is CF220195. I will explain about method 2. Method 2 requires to add a polynomial straight line on the graph which will then automatically generate the approximate function required to evaluate the area under the graph through means of integrating said function. When a function has been generated, the result will be as such. From order 2 to order 6, to get area under the line, we need to use appropriate formula. The formula we use is fx minus gx. Determine the equation from graph and insert it into the formula to get the value of the area. Lastly, find the area that the value nearest by method 1, but make sure that the value from method 2 not highest than method 1. Difference between method 1 and method 2. Method 1 is 0.90825 minus method 2 order 4 0.551. And the answer is 0.35725 mm square. Thank you.